Good morning, and thank you for joining this analytics webinar. Today, presented by Duncan Rowe, who will be covering transforming your beer production with Milestone's true hopping innovations. We will have times for Q&A at the end, so please type questions as we go. And also, just to let you know, this webinar is being recorded. So I'll hand over to Duncan.
Thank you very much, Hemi. Welcome everybody to our webinar this morning. As Hemi mentioned, we're going to have a look at one of our novel techniques here, which is to do with the craft brewery industry and looking at Milestone's true hopping innovation. So what the webinar will take place today is going to look a little bit into the background, because obviously this area of application is a little bit unique to our more traditional applications that we work with. So we'll take a look at that, and then the principle of the technique itself, what it's been applied to, and how it's going to be used in terms of the true hopping industry. Look at how this is applied with specifically to do with the craft brewery and the true hopping, and then look at a quick look at the platforms available that we've got for this, the little differences there between what they are and what they mean, and then a very quick summary. As Hemi mentioned, we'll leave the session open at the end if there's any Q&A. This will be recorded to be sent out as well, so if anybody does want a link, they can pop it into the chat and we'll pop that out to you after. Okay, so the background, really where this came from. So Milestone, our partner, based in Italy, they were founded in the late 80s. The primary focus of Milestone's platforms have always been microwave based. Typically in the laboratory market is where they started off, very much been a global leader in this area. The microwave platforms are used for a multitude of applications and industries, ranging from environmental, food, feed, pharmaceutical, petrochemical, etc. But the platforms themselves are there to introduce, obviously, heat into a specific reaction and to be able to speed that up and make it more reproducible. So globally, over the decades, have supported over 30,000 users, developed a number of patents across that time as well. One of those patents is the one that we're going to have a look at today, which is solvent-free microwave extraction, so often abbreviated to SFME. This was developed in 2002 in collaboration with Professor Chamat at University in France. So Milestone and Professor Chamat were really looking to develop a novel application that was going to perform extraction of essential oil for the fragrance industry. Now, there are a number of ways to perform extractions with this. Most of them involved solvents, some involved cold pressing, distillations, lots of different ways to attack the problem. And Milestone and Professor Chamat looked at a way of being able to speed this up, but using either water or just the in situ moisture in a particular material to extract out via distillation the essential oil. This lent itself to other industries over time. So more recently, the cannabis industry, specifically in the US and Canada, looked at using the platforms that were developed for the fragrance industry to actually isolate terpenes within the cannabis leaves. This allowed for flavors to be extracted for things like vapes, pens, chews, etc. within there. It also led to other industries like the gin adopting it for doing compound distillations. So it was particularly interesting for distillers in the gin market when the explosion happened with all these flavoursome products that were put to the market. People were trying to find different ways of creating new flavours within the gin. And this platform allowed people to do that very quickly, allowed them to take specific botanicals and do the extraction there, store them, keep them, basically make a very sort of potent mix of flavours from there. Then it moved on to what we're going to be discussing today, which is true hopping. This relates specifically to the craft brewery industry and is the latest area really where we're starting to see growth in terms of this technology being introduced. So why microwaves? It's not obviously something that's typically associated with the brewing industry. Typical brews really obviously have a very specific way, a method in terms of performing the brew, which we'll have a quick look at later. But microwaves are very unique in terms of the way that they heat, and it's why they've been so effective in laboratory environments, in the fragrance market, in the terpenes, and in the distillations with gin as well. If we compare the way that microwaves interact with what we class as conductive or typical traditional sort of heating, if you have something even at home, say like a hob, an oven, or if you've got a still within the gin industry or a kettle within the brewing industry, you are relying on the heat from the reaction, the vessel wall, whichever material it's made out of, to transfer the heat from that to the reaction mixture that you're actually trying to heat. So with this, it can take a very long time. There's delays with heat transfer, there's lags, there's cold spots. It's not a very unique, a uniform way of performing heating, especially when we're working with liquid samples. Microwaves obviously offer a huge benefit in terms of being able to directly heat a mixture, whether that be a solid or a liquid. Obviously, microwaves are a lot more efficient at heating liquids than they are solids, but they can still be used to do that. They're a very direct form, very efficient, very rapid way of increasing the temperature of a particular material. So there's a lot of benefits that we can apply across the board to multiple applications. When we're talking about the brewing industry, just so people have an idea before we dig too much in, when we talk about microwaves, we're talking about cavities that look similar to this. So Ethos X and the Ethos X 2.0 are probably more our traditional platforms that we would work off, scale from about 2 litres up to 15 litres in terms of the reactor. And then we have the XL, which is very much more of a process tool that is used for once a certain scale has been reached that people need to go up to. We'll delve into some more specifics of these later on, but just to give people a visual of what we're talking about when we're considering microwave extraction. So the principle of this technique is really to get the essential oils out of the cells that they're contained with. So we directly heat these cells so that we can rupture them, release the essential oil, and then we can take that essential oil out, and then we can separate it from the distillation. So the benefits of this, obviously, it's very short processing time, typically 1 to 2 hours. We're not directly exposing the volatile elements to the heat as well. So that obviously protects the oils, protects the aroma, the alpha acids within there. It's very efficient, and it's very, very low in energy consumption. So most of these microwaves run just off the standard 13 amp plug. So it's a very, very green process. Utility cost savings are obviously there as well. So it's very, very effective in terms of what it's trying to do. So the principle itself, if we look at it, we're going to have a botanical, whether that be mint leaves, rose petals, hops, whatever it is we're trying to work with in here. We will load this botanical or this material into a glass reactor. So this glass reactor is sealed and placed into the microwave cavity. From here, there is a connection, which you may not be able to see too clearly on the picture, but there's a glass tube that will connect from that reactor outside of the microwave cavity and up into this metal clevenger that is above. So this clevenger is essentially a reverse Dean Stark apparatus. What's happening here is when we are heating the botanical load, the microwaves are interacting with the moisture that's either in the material itself, or we would put in some liquid, some water into there, and or bathe the material in water first. But essentially, no solvent. We are just using the microwave energy to interact with the water molecules in there. They will start to steam with inside here. The cells will rupture, containing the essential oil, and the oil and the water will azeotropically come out and up through the clevenger. So they're obviously passing up in the gaseous phase up through the clevenger. And then they will hit this top part here, which is a condenser, and we'll have a recirculated water chiller connected up to this system to again be more environmentally friendly, save time, and have more control over the temperature. So the gas phase will go up, the water and the oil will condense within here, then they will drop into the burette on the left-hand side, and then we'll have the separation here of the water and the oil. The oil obviously will be collected after the process is finished, so whether that be 1 hour, 2 hours, whatever the program dictates. All the time, the water will recirculate back up through this tube, so that it re-wets the sample as we cycle through the reflux, the heating profile. So it's very straightforward, very easy, very simple to use. It provides a solvent-free way of approaching the extraction. Very, very low in terms of energy consumption and incredibly fast. So as I said, 1 to 2 hours to be able to extract out, even working up to very large scales of kilos at a time. Benefits, as we said with microwaves, is they're very, very reproducible. So when we dial up a certain power, or if we're working by a time and temperature method, we know time after time that we experimentally are going to have the same process parameters met. We can track these on the control terminal that comes with the system as well. So we're able to see very closely what power has been emitted, what temperature has been reached. And all of this gives us a very, very high purity extract. Essential oils obviously are not very abundant in anything, so yields typically range from 0.5% to 3%. So being able to get out 10 mils, 20 mils, 40 mils of an extract gives you a very high purity product to work with. So how do we apply this to the craft brewing industry? So the true hopping was a term obviously developed by Milestone themselves. The reason why they looked into this was to try and figure out a way of improving the flavour profiles, improving reproducibility, everything that we've applied to previous applications to see whether it could be applied to the brewery industry. Now, the hops obviously incredibly important part of this process. So beer is obviously made of 4 main components: so water, malt, yeast, and hops. Of these, the hops is the most expensive ingredient within the brewing workflow. It can make up to about 25 to 35% of the total beer production batch cost. So being able to control this part of the process can mean a big difference in terms of not only the flavor profiles that you can develop, but also obviously controlling the cost of production as well. The aromas that that brewers are trying to obviously create within here are driven from the volatile portion of the hop. So within the hops, like I said, typically these essential oil, these volatile oils are a very low mass compared to the starting weights, typically 0.5% to 3%. But they do allow brewers to play around quite a lot in terms of the flavor profile that they're trying to achieve. Now, where hops are used, obviously, within the brewery workflow is normally they will be put into the kettle, so this boiling stage that we see on this diagram. Now, they're put in there, obviously, because we need to convert these alpha acids into iso-alpha acids, and this is where the bitterness that the IBU, these IPAs, are getting that bitterness flavour from. The issue with this in terms of creating novel flavour profiles or aromas is that this is done at near 100 degrees. These volatile oils will all be lost at that point. They're not typically, volatile oils do not like these very high temperatures, so it can become a problem in terms of the flavour profile. So when craft brewers were looking at obviously trying to make up different profiles, they had to turn to different techniques, and one of those was dry hopping. So it's become very popular in the craft world because basically it's able to preserve these volatile oils, and we add them during the cold step, not during the high temperature boiling. So what this does is we're able to create distinctive aromas that are very different from any late hop additions or from kettle addition, and work at low temperatures to preserve these oils and really give different flavour, different freshness, different complexity to these craft beers. There are certain challenges within this, however. Those can be that it's a very inefficient way of performing this extraction of the volatile oils. So typically, it's very hard to measure. You're only getting about 30 to 40% of the flavour when you're putting the hops in during this dry hopping stage. We also see a high loss of beer, and this is because the hop pellets are very hygroscopic. They absorb water during this process, and they're obviously creating beer losses during this stage. Because we can't really control the extraction or the release of these volatile oils particularly well. It also gives very poor control over the flavour dosage, which in turn makes it very difficult to produce from run to run what flavour profile and keeping the flavour profile the same. It also requires to have more hop in there because obviously you're not getting the extraction efficiency that you typically could from other ways of doing it. And this puts equipment stress, so very high hop loads can clog up valves, pumps, etc. All of these things can lead to higher costs. So not just using more hops, but obviously having the equipment stress as well. It will increase cost, which obviously increases the cost per barrel as well. So Milestone, when they were looking at issues with this, were approached or worked in collaboration with a company in Italy, the Spadoni Brewery. So they worked with the head brewer there, Nicola Grande, very closely over a period of time, and really had a goal of looking at trying to improve or to brew smarter from what they're able to do at the moment. This was in view of looking at maximising the extraction efficiency of the flavour from the hops, so trying to get away from this problem with the pore control and the dosage control of releasing these volatile oils. Also to reduce the amount of hops that are using, because as we know, the hops are the more expensive part of brewing. So if we can control the amount of hops being used, we can control the costs a lot better within there, whilst also being able to personalize this flavor profile that brewers are looking to achieve. Obviously within this as well, increasing the brewing yield as well. So how can we improve from here in terms of the efficiency? And then also longer shelf life. So hops and any botanical really are very dependent on the season in which they are developed. This can have obviously a big impact on the amount of essential oil present within the hops, but also obviously the flavors within that hop as well. So if we can look at a way of increasing the length of time a specific hop strain may give us, then that's something that would obviously be beneficial as well to brewers. So in terms of where this true hopping fits in terms of the process, what we're looking to do here is take a developed technique that we've used for 20 plus years and apply it into the brewing industry. So the same process is applied in terms of if you're in the fragrance industry, whether you're in the cannabis industry, whether you're in the gin industry. The brewer or the distiller will choose the specific ingredients, if you like, as to what they want to work with. So they will still use a hop species that they're comfortable with. They will work with trusted suppliers. The quality of the hop is obviously ultimately the main part of how good the extract is going to be coming out. So once the particular strain has been chosen by the brewer, we then will do an offline extraction using the platforms that we showed at the start. So we will take the hop, we will place it into the microwave reactor, and then we will perform the essential oil extraction through steam or hydrodistillation, as I showed earlier. That extract will then be taken. It can be stored if it's mixed with an agent and kept at minus 18 degrees. So if you've got a particular hop strain that you want to work with that is only available in a certain month of the year, you can perform your extraction then. You can store that hop extract until you're ready to form the brewing. And obviously when we're talking about these extracts, they're not taking up litres and litres of space. You're talking of mils at a time that's able to be added to the stage when you need to. So this terpene extract is going to be placed in the conditioning or the fermentation stage. It will be put in there, obviously, because this is cooler part and protects the flavour profile. But one of the other big benefits of this is any of the hops that we used in the extraction stage when they're in the microwave, those exhausted hops can then actually be drained and placed into the boiling stage. So you're getting a dual use of the hops. So you can take out the essential hop oil from there, and then you can take the hops and you can still put them into the boiling kettle to be able to perform the bittering step as well. So there's no wastage within this, and it really again helps to drive down costs and maximize efficiencies and yields. So the platforms that we looked at a few slides ago, we'll just take a look to see where they sort of fit in terms of breweries and the size of breweries mainly. So the first one is the Ethos X, which is very much built off of the platforms that we use for other applications, whether they be digestion, synthesis, hashing, etc. This is our standard microwave platform, and it uses what we call the fragrance kit on here that you see, which is the metal clavenger. So these come in a variety of sizes in terms of the reactors. So the one that you see in the picture is a 5 litre. We've also got a smaller one, 2 litres, and then we've also got the option to go bigger at 12 litres. Now, the reason why we have different sized reactors is because there is a link between the fill level of the reactor itself and the performance in terms of the extract. So if you're working in the experimental stage, you probably wouldn't want to use, say, a kilo of material. You might want to use 100 or 200 grams until you've got the extract out and decided whether that's what you want to work with. If you're doing that, you want to work with the smaller reactor so that there's not as much dead volume at the top. This helps in terms of the reaction when things start to steam. The glass will obviously fill up with steam and essential oil. The more room at the top, the harder it is for that oil to be transported out azeotropically. So we typically will pick a reactor based on the amount of load that we're going to put in. Regardless of the way you work within here, you're working on a power-based system. So very typically 1 watt of power to 1 gram of material. The run times would range from 1 hour to 2 hours, which is the max load with the 12 litre. But what this platform gives you is a very good entry into the market for the hopping industry, but also the flexibility if you are looking to work with other botanicals. So not just using the instrument for true hopping. If you're wanting to do, say, a citrus extraction or a mint extraction or whichever material you want to work with, this platform will lend itself very nicely to being very flexible in terms of other essential oil extractions. This platform was the original sort of design for the system. When Milestone moved in more to the sort of industrial level of the cannabis industry and the true hopping industry, there was a requirement for really just working with hops, but working on a bigger scale and making it a little bit easier in terms of the handling. So this is where the Ethos X 2.0 comes in. So it is an advanced platform. It's still the same principle in terms of the Ethos X and the original patent, but it's a little bit more automated in terms of the handling. So this system only comes with a 15 litre reactor. So typically you would be working more towards a kilogram per run. The automatic closing and opening of this is done via the software, so that it's easier for the user to take the reactor in and put the reactor out. One of the other big benefits of this system is that it offers the control of the head temperature, so basically the steam temperature. Ethos X only works with a power profile based on the load that you're putting in. The 2.0 can work to a particular temperature, so you can control whether you want to work at 99 degrees, 90 degrees, 80 degrees, and then it will adjust the microwave power accordingly. So it does lend itself to giving a bit more control over the distillation within there. Obviously, being bigger system as well, you can actually process a lot more today in a day. So typically an 8-hour shift, you're looking at about 4 kilos to process. So something that's going to give you 0.5 to 3% per run. You can generate quite a lot of oil in one day. It can be used for other botanical essential oils, much like the Ethos X can, but you would have to bear in mind you would have to use a larger load within those materials rather than just working with experimental loads of, say, 100 or 200 grams. But it is possible for it to be used for these additional extractions as well. So the Ethos X 2.0 is probably the standard one for the true hopping market. Then we have the Ethos XL, which is a different type of microwave platform that's still using the same process of hydrodistillation, Clevenger condenser, and then the collection separation. The way this differs is that it doesn't use glass reactors. It basically uses a 45-litre drum, which will take sample bags. So these 10-litre sample bags allow you to work up to 4 kilos per run. So the hops would be loaded into a sack, much like a big tea bag, really. And then that will be loaded into the drum. This drum will rotate around, and then there'll be water filled from the underneath to ensure that the steaming and the extraction occurs that way. So it is a slightly different process, but it's still using the microwaves to heat up and to perform the extraction, still using the water to obviously steam and create the distillation. The benefit of this one is obviously the throughput. So you could typically run times are a bit longer, but you can do 3 a day. So you can get up to 12 kilos processed a day. So very, very, very high throughput. It's not really suited for the botanical EO extraction. Again, really just because of the scale that you're working with. You couldn't just put 100 grams of material in this because the extraction wouldn't be efficient enough to get out. So this very much is, if you've scaled up from the Ethos X 2.0 and you're sticking with the hops, you will then move up to the XL to give you more of a process tool. So, in summary, the true hopping application that Milestone developed offers really, really high savings in terms of your hop costs. So what we've seen from the real world applications and brewers that we've worked with, they are saving up to about 40% in terms of the overall cost of hops. This is down to the obviously using less, because you don't need to use as many to perform the flavour extraction, but also being able to utilize the spent hops as part of the bittering process as well. In turn, we're able to increase the brewing yield because we are using less hops. We have less beer loss within there, so yields typically improve by about 10% within there as well. We have a much greater control over the aroma profile. So because we can do very reproducible extraction, it means time after time, brewers are confident in terms of the profile that they're going to be achieving from the extract. And also now they're able to have a much longer shelf life of their preferred hops. So these extracts, as we mentioned, can be stored for months, -18. This allows you to really maximize the season of the hops that you're trying to work with. So overall, the true hopping experience offers obviously many, many benefits for brewers. Many sort of different areas to look at and avenues in terms of creating these very unique flavour profiles for craft beers, and something that's really starting to gain traction within the market itself. So that draws me to a close for today's talk. I'll like to thank you all very much for listening. I'll pass you back to Hemi now just to see if we've got any questions, and if we haven't, then we will today's presentation.
Great. Thank you very much, Duncan, for that. It was really interesting. We'll give it some time. I haven't got any questions at the moment, but we'll give it some time to see if anything comes in the Q&A box.
No problem. And as I said at the start, this obviously has been recorded, so anybody that does want this sent out after them, just request. Okay. Any questions you think are coming in there, Hemi?
No, it doesn't look like we're getting any questions. Thank you, Duncan.
Okay.
So I will end the webinar there. Thank you all for joining.
Yeah, thank you.
See you next time. Bye-bye.
Thanks very much. Bye-bye.